Hello everyone again to my YouTube channel. Today I will share with you a project end-to-end based on Block 3D dataset. So here is the source of our data as we see. I load my data from Kaggle. Kaggle is one of the famous platforms of competition in data science. That means here you have the ability to learn also on the write in your notebook and share it with other people to contribute or to comment or to give you some advice. Well, as we see here, this is the data, Block 3D dataset. Here, this is the data we have. This is the columns. We have user ID, product ID, gender, age, occupation, and also so we have city category, we have state intern, martial statue, and we have the product category 1, the product category 2, and product category 3. This is for green CSV. And also we have test. Okay, we have test CSV. So here for green. So as we see, we have two files here. We have test and green. So here in test, the goal to separate those files is just for making the predictions and send the submission of our result. Okay, so for the reason it's separated here in Kaggle. So because this dataset is used for computation. Well, here as we see, we don't have any so about dataset is not available. Doesn't mean we don't have any description for our dataset. But I will show you now what is the purpose of this dataset. So as I said before, I work in my local environment. I load my data here in my local environment in my notebook Jupyter. Well, I give you here the link for dataset. I will also put it in my description of tutorial. So if for everyone is interested to discover more this dataset. Well, here Block 3D dataset. The purpose of this data is to build in a model to predict the purchase of amount for customer. That means we need to make in this prediction, okay, to just for to because this problem is a for is a regression problem. That means based on some of this feature we have here, we need to make in the prediction. That means is we need to predict which is based on all this feature we have or is available in this dataset. Well, this is all the packages I need in this project. I need a pandas, matplotlib, seaborn. Okay. Well, this is these three packages for now. I need just to read my data and try to make some visualization to understand more. Well, as I tell you before, I load in my data here to read this train dataset. I create this variable called dftrain equal to pd.read because this file or the extension or the format of this file is CSV. That means we need to apply this function to read CSV. Well, I read my data, then I so dftrain to see the 5 top records, but it's okay here. I apply also this shape just to discover the number of records we have here. As we see, we have more than 500,000 records, and we have also 12 feature or 12 dimension. Okay, here in 3 CSV. So the same thing we do it for this CSV. That means we have this test for also to make the prediction. So we have more than 200,000 of records, and we have 12 alpha, sorry, alpha feature or dimension. Okay. Well, here, in Kaggle, as we see here, we have both of file is separated. In the process of cleaning the data and making the feature engineering, we need to build in a process one time. So we don't need to duplicate the process for train and test. So for this, we need to combine both of files in one file or to make it in one data frame. So that's what I tried to here. If we see, so concatenation of test and train data. So to do this, just I creating this variable called df or data frame equal to df train dot append this function. Okay, append df test because what I do is to ending, okay, or to add, I need to add this df test in bottom, okay, in bottom of train test. Okay, also we can use concatenate concatenate, but here I using this append, so that's work for me. Okay, well, the next step here is to discover the types of my features also and see all the columns we have using this unfold function. So the if.unfold give me all this information we have here. As we see, we have user ID, we have product ID, we have gender, age, occupation, product category, so on. Well, also if we see here, we have the number of the records we have. Okay, if we look, we have some null values here, especially in category 3, also in category 2. Okay, and also we have in the purchase. And if we look at the type, we can see here we have integer 64 for user ID, we have object, and we have also integer 64. That means we need to make in some transformation here. Well, after seeing the types for each feature we have here in our data frame, so we can go and see some basic statistics using this describe function here, provided by pandas. Well, we have the f.describe, and as we see here, we have some features here, and the describe is just work with a numeric feature. Well, working user ID, occupation, marshal studio, product 1, 2, 3, 4, and purchase. Uh, okay, here this is all the count we have here in this describe. We see the count, the mean standard deviation, the minimal 60 or 25%, 50%, median, and 74 or 75% on the maximum value. See all we have here in this describe function. Well, here we have numerical feature, the purchase. That means the purpose or the goal or the target feature is the purchase. Based on this features we have here, we need to make predictions here for this purchase. So let's try here. I using this box seaboard. Okay, this box plot. We use this kind of figure just to see if we have some outliers. Outliers that mean here in this figure uh, all these lines here. Okay, we have this continue point here. That means we have these outliers at this place. That's what we see here. Well, I do that for the purchase. That means for the target feature, the purchase here, and we have some outliers. Okay, this is one of the strategy to detect outliers in any feature. Well, also here I using this columns function df.columns to see all the columns we have here. Okay, well, this is all the columns we have here. Also here I chosen just a categorical here category column here gender age occupation starting current city year martial status product 1 2 and 3. This is all the color category of features we have. Well, let's continue. Here I using this PLT style use because I want the background of my figures to be dark or black. Okay. Well, the here for this in the univariate analysis, what I do here just I use this for making my figures more clear. Okay, and then also I use this board here count plot because I want to count uh, all the values we have. Okay, at this time we have inside of this function of count plot we have data. So I at the source of my data here is div, and I choose the gender. Okay, we have gender here as we see, and I give it title for this visualization. This is what we get here. In this gender feature, we have just two values. We have if and if. That means female and male. And the first observation here is we have the number of male is more than female. So based on this dataset we have here, because maybe we have around 60 compared to male or female, we have just 200,000. Well, this is invariant analysis because we check all the values we have here in each feature of our dataset. Okay, I use also this count or value count. I choose here the gender. I also apply this value count to check in the number of male and female we have here. Okay, this is the number of female and the number of male here. Also, I choose the age. Here, the age because it's categorical. Well, I want to see. Okay, CNS count plot data if and here as a feature is age. Okay, the age. Well, we see here the ranges of all the ages we have between 0 to 70, more than 5, between 26 and 35, 46 and 50, 61, 55, 36, 45, 18, 25. So the first observation here, the most of transaction we have here in this dataset is happen in this range of age between 26 and 35. This is maybe is the range of ages is for youth. Most people work, have a chance to have a chance to work, and need more of. So let's continue. Also here, I chose this occupation feature, and this is the result we get. So this is all the values we have in this occupation between 0 to 20. I don't know, I don't have any idea of this occupation, what it means, because as I show you here in the Kaggle, we don't have any description available for this dataset. Well, this is all the values we have, 0 and 20. And the most frequent values here is in 4 and also in 0, and we have 7 and 70 and 20, and also we have 12. This is all the observation we have for this feature. So let's continue also. So the same thing is happening with the state in the current city year. That means the period of the customer in this city. Okay, we have 2 years, we have more than 4 years, we have 3 years, we have 1 year, and we have 0 years. So the most on transaction of this, the most transaction in this dataset happen in this or this with customers have as a period 1 year, just 1 year. That's new customers coming in this area. Okay, here in this column. Well, let's continue. Also, we apply also these Marshall statutes. So the Marshall statute here, we have just two values. We have 0 and 1, and the most of values here it's happen with 0. Okay, 0. We have the most count values here in this 0. Okay. Well, let's continue. So we have this product category 1. So the product category 1, that means that all the products, all the family of these products is happen here. We give these numbers 1, 4, 5, but we don't have any other data. What it means is 1, 2, 3, but it's specified for product category 1. So the most category by the customers is 1 and 5 and 8 and 12, but the almost 1 and 5, two products, both of products it's by the customers. Okay, this is for category 1. Also for product category 2, the same syntax here. This function is easy. It's in it to count plot data equal the fx product category 2, and we give this title for this visualization. So we have 2, 3, 4, 5, 6, 8, 2, 12. The most by product it's 8. Oh, and we don't have any idea about this product, what is 8. So we don't have any information for this product 8, and exit with 8. Okay, just all we have. So let's also continue with this product category 3. Okay, and the most frequent or the most by product by customers is 60 and 50 and 40 also and 70. And we have 5 here, and we have 8, 9. That's okay. This is the distribution we have here in this category. Well, here what I do, I grouped all these pictures based on age. Well, if that group by age aggregation, we aggregate these pictures sum. Well, if I like this region and this, what I do here is I aggregate by age. Okay, 401 because here is and this is okay. But well, that's also is clear with visualization. Well, here also I do this strategy to check the null values we have using this heat map. So cborn.heatmap if is null. I pass this data frame is null. I don't care about this y-axis, so for this reason I assign this false value, and we have this c bar is to show for us how much of null value we have here. So if we look here in this x-axis, we have the features and this visualization here for product category 2 and 3 and pictures. This is the null values we have. That means we have most of null values in category 3 and 2 and product category 2. Okay, they maybe this data is not available. Okay, and we have also the null values for pages in the target for dependent feature. Well, let's continue here for this device analysis. That means we see how it is gender and pitches. It does mean how it is gender and pitches. Well, if we look here, we have female and male. Here we have this transaction happened with female, and this transaction happened with male. So if we remember, if I show you this univariate analysis based on this age, we have female compared to male, but in this case, when we apply this target feature, we look here, the most of transaction really happened with female. That means the female is most shopping than me. It's just my observation. Well, also so here I using this age and purchase, and now we hit gender as a hue. Here we have this attribute of a hue inside of this bar plot section. That means we have the age and purchase by gender. So if we look here with this blue color is female and yellow color is male. So as we see here, in most of time the male is more, so is more dominant than male here in this so for this purchase. So it's absolutely it's normal because the number of male is more than women or than female. Okay, maybe we have the same labels here compared to each. So in any range of age we choose, we can look, we have same level of purchase. Okay, so let's continue. Also, we are choosing this gender purchase. So we maybe we see that before is duplicated. Okay, we have female and male. Based on this purchase, that means how much of male is have this purchase and how much of male have this purchase. Well, so let's continue. I choose also here in the x-axis this occupation versus purchase, and here is the gender. So here we have all the variable values for occupation. So if we look here, we have this one here in this occupation 12. The male is dominant, and here for 80 we have a female is dominant, and we have some reason for this domination, but we cannot really extract some causal analysis because we don't have any idea about this feature. What is the need? We don't have any description for our data. For the reason, or for the reason, sorry, we need just to apply and work, make some transformation and work with it. Just all. Well, so if we continue, here state in the current city years, and also we have y speeches and here exchange. If you look here in the state current year, that's mean the period of staying for each customer. We have the same level of purchase based on this female gender. Sorry, have the same period of staying in the city. We have also the gender here with these colors, blue and yellow, and we have the level of purchase. We have the same level of purchase here for all the periods here. Well, also if we continue with the Marshall statute, purchase and gender, also we have maybe the same level. Okay, because for the Marshall statute we have 0 and 1, and for men or for male we have yellow color that's more dominant, more have the ability to purchase than woman, and also for Marshall statute 1. So if we continue here, we have this product category 1 and Y purchase, and here is the gender. Well, if we look here, we have this product then is more purchased by or more buy it male and female. And also we have for 50 and 60 and 80 and 1. Okay, maybe this product is necessary for like is necessary product. For this reason we have the same level of I have the same level of buy for purchase. Okay, if also we continue with product category 2 purchase, we have to for female more dominant with a little difference here. Okay, for product 2, also for product 10, and for 80 the male is more dominant here. Okay, so that's what we look here. We have little difference between women and male here in this product category too. Well, we don't have any observations here, okay, because we don't have enough data to draw some conclusions. Well, the same things with the product category 3. So for product category 3, we have male is more dominant than female, and we have some levels is near for women and men. Here for product 8, the male is more dominant also, but the other products we have maybe the same level with little difference. Okay, okay. So this is for bivariate analysis. Well, sometimes we can see some columns is not we don't have any add value. That means the we don't have any information to extract in from this feature. For this reason, it's better to drop it. So let's see this case here for user ID. Maybe we don't have any information to extract it from this user ID. So for this reason, we need to drop it, because if we let here, maybe we send it for our algorithm that may be can incorrect bias for our model. For this reason, we need to drop it. That is better. And here we can handle the category feature. That means the phase of feature engineering start here. So if we look the gender of feature, we have two values. We have male and female. We have male and female. And in our algorithms of machine learning, the algorithm is not able to understand what is mean female and male. So for this reason, we need to make this transformation and give some meaningful values, some numerical values. Here what I do, I create in this df gender equal to df gender dot replace. I using this function of replace to all the values here in this gender can be replaced by 0 or by 1. If we have female, we need to replace it with 1. If we have a male, we need to replace it with 0. Okay, this is the first syntax work for us. Also here I make this gadget. We have this method also does work well. We using here the map function. We can use the map function and we can get the same result. Here for me I use replace, that's okay. Okay, can get the same result. You can also using this gender.map f0, and here can be 1. And we can get the same result. So if we check here, I apply this heat function to feature format first for 5, because if we look for gender, we have just 1 1 1 0. That means we don't have male female male female. We replace it with this new values here, 0 or 1. So if we continue, we go to handle the age feature. So here df age, I want just the age dot, and I use in this unique function to return for me just all the values possible. So for age we have as ranges. This is the ranges. We looked at before. We see born and we see all these range of values we have here. Well, uh, also I using this value count for just to see what is the range of age has more transaction. And if we look, we have a range between 26 and 35. Okay, this is the most frequent or the most transaction happen here in this range of ages. Well, what is the idea behind here? I want just to replace because also for my algorithm cannot understand this range of ages. My algorithm cannot understand what is 66 plus, for example, or the range between 0 and 70. Cannot be understood. So for this reason, we need to replace it with some meaningful values. And what I do, I use in here this map. This is what's called feature engineering. I need to make my features more clear for my algorithm. Div age equal to div age of the map using this function of map. I, I, I create inside of this map we have this dictionary. That means the range between 0 and 70 replace it with 1, 80, 25 to 60, or 26, 35 with 3, and so on. So this is all the values we have here. So this is all the values here, and we replace it with this 1, 2, 3. Just mean we give it some meaningful values. Also, we have a technique for label encoder. So scalar provide for us this pre-processing. So from scalar and provide pre-processing, I create this label encoder equal to pre-processing of label encoder. As mean we transform these values here and give some meaningful values. Well, encode my age colon here is same as the age equal to label encoder, this label encoder here, because I create an instance from this class. Dot fit transform the age and tf dot unique. That means this is the final result here. So the same result here, okay? With both of techniques work, okay? Can also using the label encoder here. It's also there, and this is the result. That means uh, we drop this ranges of ages and we replace it with these new values here. Also, if we apply this height function or this df with height function and we go to age, you can see 000. We don't have this. Okay, if we return to see, so we don't have this 070, 070. We replace it with new values here. We have 0, 1, 2, 3. That's the point of the range of age we have. If we continue in this process of feature engineering, we can go also to see the city category. Okay, stf.city category.unique. Uh, if we check, we have just three values. We have A and C and B. That means inside of this city category, we have just three values. Also, pandas provide for us this get dummies function just to make transformation from this to give you some meaningful values, because the algorithms cannot understand what is mean A, what is mean C, what is mean B. Well, here what we do, so PD, so from pandas we have this function of get dummies. I give it my target variable or my target feature, not what they want to transform. So in our case, we have the city category, so the F category, the city category, and also we drop first. What is mean that here, if we go, we drop this first one. If C is if A is the first one, we drop it and we conserve just C and B. Why? Because here what we do, we give 0, 1. Okay, we use 0 and 1. I will show you what is the new values here created in this reference. If we drop C, I will show you now. Okay, so make it more clear. So here what I do, because I create this new column, I need to concatenate it with my old data frame, and that's what I do now. Df equal to pd dot concat function df my data frame and tfct. This is data frame for what I create, and I will add it in axis 1 because axis 1 is for features. df.head, this is the result what I get. So if we go in the last of my data frame, this is b and c, because that it's coming here from this get dummies. A is not able here, or is not available here because we drop it. So at this time, if we have 0 in B and 0 in C, that means it's 1, it will be in A. Okay, so that's why we use this syntax. We do this strategy just to describe the number of features. Okay, I hope that's clear for you all. Well, if we continue in this process, so if we create this B and C, that means we don't need again this. We don't need this city category. For this reason, we need to drop it. Okay, that's what we do here. Df.drop city category. Okay, we drop this column in the axis 1, because in this column, and in place equal to 2 just for confirm is dropping. And if we look here, we don't have it. The city category is dropped. Okay. Well, so here, if we continue in our process, okay, we drop this column of city category because we don't need it yet. Well, if we continue, also, as I said before, we have some features we don't need it in our predictions, like user ID, like product ID. We don't need it because we don't have any information to extraction from this feature. We need to drop it. Okay. Also here, I want to check in the null value we have here using the Seaborn. I show you before with Seaborn all the null value we have in category 2 and category 3. And also we can apply this function of isNew to give me this result here in this product category 2 and product category 3. And for purchase also. This is all values, or this is all null values we have here in this data set. Well, if we start with product category 2, okay, let's see these numbers of null value we have here. So I apply this product category 2 dot unique to show me all the unique value we have in this product category 2. Okay, this is all the values here available for my available in my product category 2. So also I can count the number of each of these value we have here. And to do that, you can use just data frame dot product category 2 dot value count. So the first one is 8, and we have 14, we have 2. So, and 50 also. This is all the values we have here. This is counted. That means the number of each of these product category 2. The most frequent one is 8. So why I do that? Because I want to replace the null value with some value. Because we cannot give for my model some null values here, and we want to make some prediction, but it's not possible. So we need to replace some null values with some. Well, what we do here, because 8 is the most frequent one, then we can replace the null value with 8 because it's the mode of this feature. Well, if we check here, so the product category 2 dot mod, I use it, or I apply this function of mod. I use 0 here because I want just 8. Because if we using just mod, we can see the index and the value. But for me, I want just the value. Okay. Since the most or the mode of this category 2 or product category 2 is 8. But the problem here is if we want really to replace this value in my nail value in this category product 2, I don't know if this product is available in my store or not. That is the problem because as I tell you before, we don't have any other information from my data set. This is all the data available for us. Okay, then, and we don't have any other option. So we need just replace the null value here with 8. Okay, and to do that, we use this syntax. Also, we have this give product category 2 equal to product category 2 dot fill now. We have this function of fill now that's help us to replace the non value with some other values. So in our case, we replace the non value with the mode. Okay, fill now the product category 2 dot mode. Okay, we replace it with the most one. And if we check again the null values here for this product category 2, we get 0. That means we handle all the null value we have here. So the same things happened with product category 3. Product category 3 also we are using this product category 3 dot unique. This is all the values we have here. Okay, and also we draw the same conclusions. We apply this value counts just to count the number of all the value possible here, the most frequent values, and the mode for this feature is 16. That means the product 16. I don't know what it means product 16. We don't have enough information to see is that possible, is that available in our store or not. But it's okay. Technically, that's work. Okay. We replace the most replace the non-value with the most frequent value here in our case also. DF product category 3 called the DF product category to fill now. DF product category 3 dot mod. Replace the non-value with mod. If we go again to check in our data frame, df.heat, this is all the data we can leave here. Home gender occupation. So everything is ready for prediction now. Yeah. Also we have we yeah here stay in the current city. Also, if we go check in all the value available here in this feature, we have 2 plus 4 3 0 1. Okay, and we can replace now this 4 plus with 4. Okay, replace it here. We replace this 4 plus with 4 in our data frame. And if we write in this filter, that means we have a non-value here with this condition or in this value. So in the state currency city 4 years 4 plus, I write in this filter here, and the result is 0. That means we don't have any data with this condition. Okay. Well, if I go again to check the data type of my data here, we have the gender, integer, integer. We have also this state in the current city. Here, so we need to make it numerical. Okay. And also for this B and C here, we have unit integer 8 for B and C. We need to transform these 3 features. And to do that, we can use this syntax. We have the if stay in the current city years equal to pd dot numeric, because I want to make this feature numeric. I need to make it as a numerical feature. If I check again, I go to this in current city years. The result is integer 64. Okay. We need to make it from object to integer. Also, the same things for B and C. For B equal to other type integer. So we have a lot of standards to work with. Every time I try to using something different, we have to numeric. We have other type also here. We have other type integer or float. Okay. Well, see when we make it as integer. And if we check data type for all the features here, we have all these types is float or integer. Okay, so let's also continue. Here we have a concept of heat map or the correlation. The correlation does mean what is the relationship exists between two features. And to do that, heat map help us to see visually this relationship. Well, here I create a data frame one and it trace just the features I need. Okay, I need to see all the features here and they make it as a correlation because I want the correlation of all these features here and I make it here in this SNS. So figure X here just to make my model or my visualization or my feature more clear. And also I use this keyboard dot heatmap data equal to dif1. This is dif1, this correlation, and not true and cmap is has if. Well, if you look here, this is the relation or the correlation we have between all these features. If we choose, for example, this gender with C feature, we have this value of 0.0000818. As mean this relation between gender is C is very weak. If we go also between the age and C, we have 0.12, and this bar give us the level of relationship here. If this color is red, that means we have strong relationship. As we see here in this diagonal of this matrix, all these reads color are all these diagonal reads and with one value, this means a strong relationship because this feature and the same feature is give us a strong relationship. For this reason, this diagonal is a read one. Okay, if we go here in this relationship, Marshall statue and age. Okay, Marshall statue and age just mean we have meaningful relationship. Is a medium relationship. If we see here in TC bar, we have can classify it here between 0.2 and 0.4. That means we have meaningful relationship. Also, if we go here for this product category one and purchase, okay, at this time we have a negative relationship. That means uh, if we buy some product category one, the purchase it's down or is decreased. Okay, we have a negative relationship here. And here also we have a minus 0.19 and we have here a meaningful relationship between statue and age also. Okay, well, and read is read uh, between B and C we have this relationship between C and B we have negative one and between C and C is give us one. Okay, we have also this C and purchase we have weak relationship. So here the heat map show us how it is this relationship between all the pictures we have here. So really it's help us to choosing strong or meaningful features our mode. So here if we continue also, um, so some duplicated visualization here because we choosing the age and the purchase and the gender. So we see that before. Okay, we have also set versus of occupation. You see that before all this visualization I showed it before is duplicated. Well, here we need to feature scaling. So the feature scaling because we clean and handle all the main values we have in dataset. At this time we need to separate the files again. So in df test I go to purchase. I want just the nil purchase here and make it in a df test because this df test I want to submit it to my competition because we don't have any values for this purchase. I need to build in my model in my train dataset. Then at this time we can send the result here in this or this the df test. Well, if we look here, we go to purchase, we have just the null value here because I choose just purchase. I want just the null values purchase. Okay, df train equal to df tilde. I use this symbol of tilde. That means not is the opposite of this syntax. Okay, well, df train equal to df purchase is nil. That means tilde. We want just the meaningful or not null values. And if we go df train dot heat, if we go to purchase, we can have some values here in this purchase. Okay, so if we look here, why I store this, um, I create this y variable equal to df train purchase, and if we look the shape of this is the shape of y. This is the records, or the records we have, and the rows. And here for x, I drop this purchase because this is the target or dependent feature. This is independent features. That means I want to drop the purchase from this drawing. And if we go here, we have the same records, but here we have just 10 features or 10 dimensions. Okay, I hope that's clear for you. Well, I go also here in to splitting my data from sklearn.model selection. I import this to into split. I divide it for four parts. X train, X test, Y train, Y test equal to 20 split. X, I give it X as independent features, and Y the target feature. Test size I want just for testing this. I want just 0.33, and the rest for training. And the random state I give it this value because I want to have the same result each time I run this cell. Here I use also this scatter plot. We have this technique of scatter plot to show visually this relationship exists between two features. Here I choose this product one, and also I choose this purchase. The target independent and dependent variable. This is the purchase dependent feature. Here independent, and they want to discover the relationship exists between two features. Here, this is the part of algorithms. Okay, quickly I will show you what I do here. Um, I use this 3 decision. 3 decision, one of the famous algorithms we have. Okay, it's based on statistical part, and we have entropy function. Also, I will go deeply to explain for you these algorithms how it work. But here in this competition, I will show you just how we can work with this algorithms. Well, from sklearn, I choose these three. First, I import this package of NumPy, and I choose this three package. Regular model. This is variable equal to three decision regression because as I tell you before, this is a regression problem. Well, in this tree, I want to choose this decision tree regression. I want also to print the default parameters we have inside of this regression. For three decision regression we have. We want to create a model. How we can do that? We have the tree. This variable equal to regular model. This model here. this instance of this model dot fit x2 and y2 from this plugin of data. I want also to make in this prediction d3 dot predict x test. I want to predict just the x test. Okay. Well, the predictor is this is all the predictors we have based on all these features we have here: gender, age, occupation, and so on. Okay. Well, also I want to measure the performance of my model in a regression. What we do, we using this R value square and accuracy. Well, from scalar input matrix, R value or R square value here is a matrix dot reduce score. We need to score between y right and the predict one here, e3 dot predict x, and also the accuracy is 100, sorry, yeah, 100 minus the mean of this y test minus the prediction divided by y test times 100. This is the accuracy one. Well, if you go here, this is the accuracy here, and this is R value. I discussed before in this accuracy and the value in one of the my tutorials. Okay, anyone interested to understand what is mean to A score and accuracy, we can go to this playlist of Torch. At this time, I kind of found the tutorials explain deeply what is the mean of metrics. Okay. Well, here also, I want to see the feature importance in these algorithms. So I create this feature importance with what PD series. The D3 dot feature importance, we have this function of feature importance. The index is predictors, call these predictors here. Okay, and a feature imports, I plot it here in this bar, horizontal bar. Well, if we check, most important feature here is the product category one, and we have occupation, and we have the end current year and age and so on. Okay, this feature importance give us an idea what is the most useful features in our prediction. Okay, this is for decision tree regression. Also, I use linear regression and reach both algorithms. Also, I create an instance for linear regression. I print these default parameters we have. Also, I create this variable of algorithm in linear regression equal to this instance of this algorithm for linear regression. We have fit is try and y try. Well, I make this prediction also prediction equal to this algorithm of algorithm linear regression dot predict text. And also I measure my matrix here, the same syntax. I don't have any so here this is the R value and this is accuracy. Accuracy it's minus 70, that means weak, and the R value also is weak. That means the linear regression, so we cannot use it in our case here to make a prediction. So for this reason, in real time, on a real project of data science and machine learning, we need to apply a lot of algorithms and choose the best one for. Here I work with trade decision. Also I work with the linear regression in reach. I also here use the each reach also. The reach, so the reach is we apply penalty L1. So I discussed that before. Okay. That mean here in the equation of my algorithms of linear regression, we adding this L1 norm. That mean we choosing the most feature importance with sum of absolute value of slope of each or all the features we have here squared. Sorry, with just with absolute value. Okay. Well, I do the same things here. This is Ridge. I create an instance from this ridge here. I print the default parameters, and also I create this here ridge dot fit extra and white line here to fit. That means make transformation here. Try to discover this shape or pattern of database on this fit function here. Also, I make this prediction here. Same things. I try to measure accuracy and square too. Also, it's weak. We have the same things. And here also we have some boosting technique. Boosting technique is the most useful technique in the competition and in the interview in an interview of work. The most of company and enterprise can ask you for this boosting technique and backing technique how it's work. So here in this case, I apply this ADA boost and gradient boost and random forest. I create an instance for ADA boost regression here. I create also this fit predict and I measured accuracy. This is the result here. So we have the R value here and we have the accuracy also weak. I create also an instance from this gradient boosting regression. Okay, I predict and I measured accuracy. Well, this is the result here. We have here 2.64 and we have 20 or 58% accuracy. Also, I create the instance from this random forest regression. Okay, I make this prediction here and I measure the matrix based on the L2 and accuracy, and this is the result here. We have the R values where we have 0.78 and 60 and 66% of accuracy. Also, we have Kine-Neighbor algorithm. Okay, neighbor algorithm. So inside it is or this Kine-Neighbor regression. Kine-Neighbor KNN is based on the measure the distance between the points in plan or in space. I will go deploy inside of each of all these algorithms. Okay, in the next session. Well, just I work with you here in this project to show you how all these things happen. Okay. Well, I create also the instance from this Kine-Neighbor regression here. I make the prediction and I measure the accuracy and the F2 square. I have R2 value 0.68 and accuracy is 57%. Well, if we go also to this technique of bugging technique here, XGBoost, one of the famous algorithms we can face. Okay, I will go deeply inside of each of these algorithms and I will show you how does work. Well, just so here also I create an instance from this XGBoost regression. I make this fit and I make this prediction here for this test value and I measure the matrix for R2 value and accuracy. And this is the value here. Prediction for XGBoost regression, we have R2 value 0.67 and 63% of accuracy. So for this XGBoost prediction also we can see the feature importance here. The same of pre-decision because the idea behind this regression or technique of posting, we have weak learner. We have a lot of algorithms inside of this XGBoost can be decision tree in the most of time. We have a lot of decision trees work together to make the result on the accuracy pair. This is the idea behind this. Well, for this reason, we have the same feature here. Okay, for that category 1, 2, 3, and so on. Here we have light votes. So, okay, we have another algorithm, LGBM regression. I create an answer from this one. Okay. I fit a project and I measured accuracy, and this is the result here. 0.664 as for F2 value, and we have 62.88 for accuracy. So to make this prediction based on this dataset we have, I choose here a random algorithm random forest because the best accuracy is created with this algorithm. Okay, and to make or to build in the prediction here to send or to submission our result in the competition. So I create this div test one equal to this algorithm predicted the test. We give the prediction for the test, and we see the shape here. Div test one dot shape. This is the result, and shape of this the test is here. Well, we have the same values, and we add in this purchase div for purchase equal to div one. Okay, that means we replace because the purchase we don't have it before, and we need to make in some predictions. So the predictions here is stored in this variable of div test one. Then we need to add it in our data frame. So if we look here, we have this purchase here. Okay, this is the result. So I hope that's clear for you all. Okay, this notebook I will share it with you. I will put it in my GitHub, and also I will share with you the source of this data in Kaggle for everyone interested to train and discover more on this data or making some other concepts. Maybe why not? Okay, I hope that's clear for you all. Happy learning for everyone again. See you again. Bye bye.